Welcome to the Chapter 26 lecture about income and expenditures. This chapter is very technical and filled with much more economic vocabulary compared to previous chapters. Take this material slow and do not hesitate to ask questions. The marginal propensity to consume, MPC, is the fraction of extra income that is consumed or the fraction of extra income that is spent. For example, if you were given an extra $100 and spent $70, your MPC would be 7/10 or 0.7. The formula for MPC is the change in consumption divided by the change in disposable income. Marginal propensity to save, MPS, is the fraction of extra income that is saved. Of that $100, if you save the remaining $30, your MPS would be 3/10 or 0.3. The formula for MPS is the change in savings divided by the change in disposable income. Due to the relationship between marginal propensity to consume and the marginal propensity to save, MPC plus MPS will always equal 1. MPC and slope. The slope of a straight line is the vertical distance between any 2 points divided by the horizontal distance between those same 2 points. The MPC is measured graphically as the slope of the consumption function, since consumption is measured on the vertical axis and disposable income is measured on the horizontal axis. The MPC is always constant along any consumption function, since it is a linear line. Aggregate expenditures, consumption. An individual makes a decision about how much to spend on consumption primarily on their level of income, but also on how much savings they have. Disposable income is the income that is actually available for consumption and savings. In other words, it is the income minus taxes. Disposable income minus consumption would equal the level of savings. The consumption function shows the relationship between consumption and disposable income, other things constant. Consumption is the dependent variable and disposable income is the independent variable. Consumption is measured on the vertical axis and disposable income is measured on the horizontal axis. The consumption function is upward sloping, labeled C. The slope of any consumption function is the marginal propensity to consume. Aggregate expenditure and income. Before developing this model, let's start with a list of assumptions. Each dollar of spending translates directly into a dollar of income. Gross domestic product equals aggregate income, and the government runs a balanced budget. The aggregate expenditures line, or AE curve, shows how much households, firms, government, and the rest of the world plans to spend on U.S. output at each level of real GDP or real income. The slope of the aggregate expenditures curve is the marginal propensity to consume, since consumption is the only component of the AE line that varies with income. The income expenditure model. Aggregate expenditures on the vertical axis, real GDP or real income on the horizontal axis, a 45-degree line, which I will describe in just a moment, and the AE curve in blue. The 45-degree line identifies all points where spending equals real GDP. In other words, the amount people spend is the same as the amount of goods and services produced. There will be no change in inventories. This will be illustrated as point E on the next diagram. What happens if spending is greater than real GDP? If spending is greater than the amount of goods and services produced, something has to give. Firms will use inventories to meet demand, but they cannot do so indefinitely. Firms will increase production to make up the difference. This will be illustrated as points A and B on the diagram. What happens if spending is less than real GDP? If spending is less than the amount produced, unsold goods will accumulate. Rather than let inventories pile up, firms will decrease production. This will be illustrated as points C and D on the diagram. Reviewing this diagram in more detail, aggregate expenditures on the vertical axis and real GDP on the horizontal. The 45-degree line representing all the points in which the amount spent equals the amount produced, and the blue aggregate expenditures line. At point E, consumers are spending $14 trillion on goods and services, and the economy is producing $14 trillion worth of goods and services. At point A, the economy is producing $13 trillion in goods and services, but consumers are spending $13.2 trillion, point B, on goods and services. Therefore, firms are using inventories to meet demand and will increase production. At point D, the economy is producing $15 trillion, but consumers are demanding $14.8, point C. Therefore, inventories are starting to pile up. Firms will respond by decreasing production. The simple spending multiplier. If there's an increase in spending, the aggregate expenditures curve will shift upward, causing a multiplied effect on GDP. Suppose firms become optimistic about the future and increase investment spending. The aggregate expenditures curve will shift upward. You can see there are many points between E and E prime. I will explain points F, G, H, I, J, and K on the following slide. To understand the shift of the AE line, I'm going to break it down in 3 rounds. Round 1. Firms increase investment by $100 billion. Spending will exceed output. This is shown on the diagram as the distance between point E and point F. Firms will use inventories to meet demand and will increase production. The increase in production is shown from point F to point G. This increase in production will create $100 billion more in income. Round 2. Let's assume the marginal propensity to consume is 0.8. Those who earn the $100 billion in new income will consume 4/5, or $80 billion, and save the other 1/5, or $20 billion. This is shown as the movement from point G to point H. Firms respond by increasing output by $100 billion, which is point H to point I. Round 3. 4/5 of $80 billion will be consumed, which is set $64 billion, and is shown as point I to point J. Firms increase output by $64 billion, which is point J to point K. This process continues on and on. As long as spending is greater than output, production will increase, thereby creating more income, which will generate even more spending. We can use a simple spending multiplier to determine the total amount of spending will increase by. The spending multiplier equals 1 divided by 1 minus MPC, or 1 divided by MPS. In our example, the marginal propensity to consume was 0.8. Therefore, the spending multiplier equals 1 divided by 1 minus 0.8, which equals 5. Total spending equals the initial spending amount multiplied by the multiplier. Total spending equals $100 billion times 5, which equals $500 billion. You can go back in the lecture and look at the diagram again. Point E prime is 14.5 trillion. This is the end of the Chapter 26 lecture. If you have any questions or concerns, please post a question in the Ask Professor Pakula discussion board.